Imagine you walk into a vast forest at night. Not a normal forest, I mean one of those ancient, impossibly huge ones where the trees are so tall they disappear into darkness. You stand there, perfectly still, no wind, no insects, no rustling leaves, no distant animal calls, just silence. Now here's the strange thing. If you were really standing in a place that large, that full of life, it wouldn't be silent at all. It would be noisy beyond belief. Something would always be happening somewhere. A branch snapping, wings fluttering, creatures whispering to each other in their strange little languages. Total silence in a place full of activity would be suspicious. And that's exactly the problem we face when we look at the universe. Because when we look up at the night sky, what do we see? An enormous place, almost unimaginably large, filled with hundreds of billions of galaxies, each with hundreds of billions of stars, planets everywhere, chemistry everywhere, time, an absurd amount of time, billions of years for things to happen. In other words, if there were ever a place where something interesting ought to be going on, it's out there. And yet, when we listen, really listen, what do we hear? Nothing. No signals clearly saying, hey, we're over here. No giant cosmic engineering projects lighting up the sky. No unmistakable signs of civilization spreading from star to star. Just silence. And that silence is deeply, profoundly weird. Now, when something in physics feels weird like that, it's usually because there's some hidden assumption we're making without realizing it. Like when you first learn that a spinning coin stays upright not because it wants to, but because of angular momentum, something you can't see but that absolutely refuses to go away. So here's the strange question that scientists have been wrestling with for decades in a universe this big, this old, and this full of ingredients for life. Why isn't it buzzing with activity? Why does it feel like we're standing in a cosmic forest that should be full of sounds, but instead it's eerily quiet? Now let's make this puzzle feel more concrete. Imagine you're standing on a beach, a huge one. It stretches as far as you can see in both directions. And scattered across it are millions and millions of bottles. Each bottle contains the right mix of chemicals that, under the right conditions, can start producing life. Tiny little organisms. Over time, some might evolve into intelligent creatures. So you start opening bottles. Most are empty. Some have little microbial scum. But suppose this beach has existed for billions of years. Plenty of time for life to evolve. Plenty of time for intelligent creatures to arise. Plenty of time for them to build tools, machines, maybe even radios. And here's the important part. If even one of those civilizations learned how to communicate over long distances, they'd probably start broadcasting. Maybe accidentally at first, like we do with radio and television leaking into space, and then deliberately. Over time, signals from all those bottles would overlap. The air would be full of chatter, static mixed with voices from everywhere. You wouldn't need to open every bottle to know life existed. You'd hear it. But when we listen to the universe using giant radio telescopes, it's like tuning a radio and hearing only static, natural static, cosmic noise from stars and galaxies and the Big Bang itself. No clear voices, no unmistakable artificial patterns. Nothing that screams, someone else is out there. And that is what makes scientists uneasy, because it doesn't fit our intuitive expectations. You see, intuition tells us something simple. Big holds lots of time, lots of chances, and lots of chances should mean lots of outcomes. If you flip a coin once, you might get heads. Flip it 1,000,000 times, and you absolutely expect to see both heads and tails many times over. That's just how probability works. The universe has had not just millions of coin flips, but trillions upon trillions of opportunities for life to arise. So where is everybody? Now, here's where it gets truly fascinating and a little unsettling, because the silence might not just be an accident. It might not be a coincidence. It might actually be telling us something very deep about the laws of physics themselves. That's the part that really grabs physicists. Because when nature behaves in a way that seems improbable, there's usually some hidden rule, some invisible constraint shaping what can and cannot happen. And the possibilities are, well, they're both thrilling and terrifying. Maybe life is extraordinarily rare, far rarer than we ever imagined. Maybe intelligent civilizations tend to destroy themselves before they can spread. Maybe the physics of interstellar travel is much harsher than science fiction makes it seem. Or, and this is the really eerie one, maybe the universe has built in barriers that prevent advanced life from ever becoming visible on a cosmic scale. Invisible walls written into the fabric of reality. Now that's a curious idea, isn't it? Because we usually think of physics as the set of rules that allow things to happen, like gravity letting planets form, or electromagnetism letting atoms stick together. But what if physics is also the thing that quietly prevents certain things from ever happening? What if the silence of the universe isn't just empty space, but a consequence of deep, unavoidable physical limits? And that's where the mystery becomes less like astronomy and more like a detective story. Because now we're not just asking, where are the aliens? We're asking something much more interesting. What is the universe allowed to do? What can energy accomplish across vast distances? How fast can information travel? How long can complex systems survive before entropy tears them apart? And perhaps most intriguingly, is there something about the nature of time, energy, and probability that makes a loud, bustling universe fundamentally impossible? When you start thinking about it that way, the silence stops feeling like a coincidence. It starts to feel like a clue pointing towards some deep truth about reality itself. And once you notice that possibility, you can't unnotice it. Because suddenly the quiet night sky isn't just peaceful anymore. It's whispering a question, one that physicists have been trying to answer for decades. And the strange thing is, the more we dig into the physics, the deeper we look into energy, entropy, light speed, cosmic distances, and the fragility of complex systems, the more it begins to seem that the silence might not be surprising at all. In fact, it might be inevitable. And that realization opens the door to a whole set of ideas that are so counterintuitive, so deeply tied to the fundamental laws of nature, that they completely change how we think about life, the universe, and our place within it. Alright, so let's play a little game of imagination, because in physics, imagination is often the quickest way to discover where your intuition is secretly betraying you. Suppose you had a magical flashlight. Not an ordinary one, this one is perfect. Infinitely bright, infinitely precise. You turn it on and it sends a beam of light straight out into space forever. No spreading, no dimming, just a perfectly straight, unwavering beam. Now imagine you switch it on right now and point it toward a distant star. What happens? Well, your first instinct might be to say, eventually someone out there would see it. That seems obvious. Light travels, it carries information, and if there's anyone out there looking, they'd notice this enormous artificial signal cutting through the darkness. But here's where physics begins to gently smile and say, not so fast. Because the universe is not just big, it is ridiculously big. Light travels fast, yes. The fastest thing possible, about 300,000 kilometers per second. That sounds mind-bogglingly quick. But space is so vast that even at that speed, crossing a single galaxy takes about 100,000 years, and there are billions of galaxies. So if you shine your flashlight today, its beam won't even leave our cosmic neighborhood for tens of thousands of years. It won't reach the nearest large galaxy for millions of years, and it won't cross the observable universe before the universe itself changes dramatically. In other words, even if civilizations are everywhere, their signals take enormous amounts of time to reach each other. So right away, we stumble onto our first big clue. The universe has a built-in speed limit, and that speed limit, the speed of light, is not just a suggestion, it's an absolute rule. Nothing carrying information can go faster. This changes everything, because it means the universe isn't like a room where you can shout and everyone hears you instantly. It's more like a vast ocean where messages drift slowly in bottles. And here's the thing that really makes your brain itch. While those messages are traveling, the universe itself is changing. Stars are being born and dying. Planets are forming and being destroyed. Civilizations might arise, flourish, and disappear, all before their signals even reach the nearest listeners. So now, the silence begins to feel less mysterious. It might simply be that we're all out of sync with each other. Like people trying to hold a conversation by sending letters that take 100,000 years to arrive. You send a message. By the time it reaches someone, you're gone. They reply. Their reply reaches a world that no longer exists. So maybe the universe isn't silent because nobody is there. Maybe it's silent because time and distance make communication almost impossible. But then, of course, physicists can't resist pushing the idea further. Because once you accept that signals take time, another curious question pops up. What happens to those signals while they travel? Do they stay nice and clear? Or do they slowly fade into something unrecognizable? And here's where we encounter another quiet but relentless law of nature, entropy. Now, entropy is one of those words that sounds fancy and intimidating, but its basic idea is wonderfully simple. It just means that things naturally spread out and become disorganized over time. Hot coffee cools down. A drop of ink spreads through water. A neat stack of papers turns into a messy pile if you leave it alone long enough. Nature loves disorder. And signals, whether they're radio waves, light pulses, or any other form of information, are no exception. As they travel through space, they spread out, they weaken, they mix with background noise. They become harder and harder to distinguish from the random static of the universe. It's like whispering across a gigantic stadium while thousands of people are shouting. Even if your voice starts loud, by the time it reaches the far side, it's lost in the noise. So now we have another piece of the puzzle. Even if civilizations are broadcasting, their signals may simply fade away before reaching anyone. Not because of any dramatic cosmic conspiracy, but because entropy quietly dissolves information. It's a gentle but unstoppable process. And when you combine that with the immense distances involved, you begin to see how communication across the universe is not just difficult. It's almost absurdly difficult. But the universe still has another trick up its sleeve. And this one is particularly sneaky, because it involves something we usually think of as empty: space itself. You might imagine space as a passive stage, just a big empty arena where stars and galaxies sit. But modern physics tells us something very strange. Space is not static. It stretches. It expands. The universe is growing larger over time. And here's the subtle but astonishing consequence of that. As light travels through expanding space, its wavelength gets stretched too. It becomes redder, weaker, less energetic. This is called redshift, and it means that even if a civilization sends a strong, clear signal, the expansion of the universe gradually dilutes it. It's like drawing a detailed picture on a rubber sheet and then stretching the sheet larger and larger. The lines become thinner, the details blur. Eventually, the picture is unrecognizable. So now we've uncovered something deeply unsettling. The universe itself actively erases information over time. Not intentionally, of course, it's just a consequence of how space and energy behave. But the result is the same. Signals fade, patterns dissolve, messages disappear into noise. And when you put all of this together, the speed limit of light, the vast distances, entropy spreading information out, and cosmic expansion stretching signals beyond recognition, the silence of the universe begins to feel less like a mystery and more like an inevitability. It's not that nobody is speaking. It may be that the universe is simply too large and too restless to preserve the echoes of those voices. But there's an even deeper layer to this story, because so far we've only been talking about communication, the difficulty of civilizations hearing each other. But what if the real issue isn't just hearing? What if the real challenge is surviving long enough to be heard at all? And that's where physics becomes truly sobering, because when you look closely at how complex systems behave over time, whether they're stars, ecosystem, or technological societies, you find that maintaining order is incredibly hard. Nature constantly pushes toward chaos. Energy gradients flatten. Structures break down, stars burn out, planets change, biological systems evolve, but they also face extinction. Complexity, it turns out, is fragile, and sustaining it over millions or billions of years requires a delicate balancing act against entropy. Now think about what it would take for a civilization to become visible across the universe. It would need to survive not just thousands of years, but millions, maybe even tens of millions. It would need to maintain technological stability, avoid self-destruction, and continually manage enormous energy resources. And here physics whispers another uncomfortable truth. Long-lasting stability on that scale is extraordinarily rare. Not impossible, but very, very unlikely. Because the more complex a system becomes, the more ways it has to fail, and the universe has a lot of time to test those failure modes. So perhaps the silence is not just about signals fading or distances being too large. Perhaps it reflects something deeper about the nature of complexity itself. Maybe civilizations flare into existence like sparks, bright, brief, and quickly extinguished. And if that's true, then the universe wouldn't be full of ancient, long-lasting voices. It would be full of fleeting ones, voices that rise and fall long before their light can reach us. Which means that when we look up at the night sky and see silence, we might not be seeing emptiness. We might be seeing the aftermath, the quiet that comes after countless brief moments of cosmic activity, like walking into a theater long after the performance ended, with only the empty seats left behind, and that idea that physics itself might conspire to make a loud universe impossible leads us into an even stranger and more counterintuitive set of truths. Because when we dig deeper into energy, probability, and the ultimate limits of what physical systems can do, we begin to encounter a possibility that is both fascinating and chilling. One that suggests the silence of the universe might not just be likely. It might be the natural, unavoidable outcome of the laws of reality. And to understand why, we have to venture into some of the most surprising and mind-bending ideas physics has ever uncovered. Would you like me to continue? Now here's where things begin to get really strange, the kind of strange that physicists secretly enjoy, because it forces you to rethink everything you thought was obvious. Let's go back to something very simple. Energy. You know, we usually think of energy as something you can just keep using. You burn fuel, you get heat. You charge a battery, you power a machine. You build bigger generators and you get more energy. It feels like a straightforward idea. As long as there's fuel, you can keep doing things. But the universe has a rule about energy that is far more subtle than that. It's not just about how much energy you have, it's about how useful that energy is. And this is where entropy comes back, not as a quiet background actor, but as the main force shaping the long-term fate of everything. Because energy doesn't just disappear, but it does become less and less usable over time. Imagine you have a perfectly hot cup of coffee in a cold room. There's energy in that temperature difference. You could, in principle, run a tiny heat engine from it, do some work, power something. But as the coffee cools and the room warms slightly, that difference fades. Eventually, everything reaches the same temperature. At that point, there's still plenty of energy around. The atoms are still moving, but you can't use it to do anything. No gradients, no differences, no push left. It's like a river that has reached the ocean. The water is still there, but the flow is gone. And this simple idea scales up in a way that's almost terrifying, because the entire universe behaves the same way. Stars shine because there's a difference. Dense fuel in their cores, vast cold space around them. But stars don't last forever. They burn their fuel. They fade. Galaxies evolve. Black holes slowly evaporate. Over unimaginably long timescales, the universe drifts toward a state where everything is evenly spread out, energy differences disappear, and nothing interesting can happen anymore. Physicists call this heat death. It's not dramatic, no explosions, no sudden collapse, just a slow, inevitable fading into uniformity. Now here's the key insight that ties this to the silence of the universe. Complex systems like life, intelligence, civilizations depend entirely on energy differences. They need flows. They need gradients, they need imbalance. Life exists because Earth sits between a hot star and cold space. That temperature difference drives everything: weather, chemistry, metabolism, evolution. If the sun suddenly emitted the same temperature as the background of space, life would end instantly. Because without energy flow, complexity collapses. So now think about an advanced civilization. To build massive structures, communicate across space, or expand beyond its home planet, it would need enormous energy gradients. It would need to continuously harness and control energy. And here's the catch: maintaining that control gets harder over time. Because entropy constantly pushes against order. Machines wear down. Systems become unstable. Information degrades. Errors accumulate. This is not a technological limitation. It's a physical one. Even the most advanced civilization imaginable cannot escape entropy. It can only delay it. And the longer it tries to sustain complexity, the more energy it must spend just to maintain itself. It's like trying to keep a sandcastle intact while waves continuously erode it. At first, you can patch it easily, but over time the effort required grows. Eventually, the cost exceeds what you can manage, and the sandcastle disappears. Now scale that up to a civilization trying to last millions of years. The odds become extremely small, not because of wars or mistakes or accidents, though those may happen, but because physics itself is relentlessly working against long-term stability. Complex systems tend to break down, always, and this leads to a profoundly counterintuitive conclusion. The universe may naturally suppress long-lived, highly visible civilizations, not through any dramatic catastrophe, but through the quiet, persistent pressure of entropy. Think about it this way. Imagine a field full of fireworks. Each one ignites at a random time. When a firework explodes, it shines brilliantly for a few seconds, bright enough to be seen from far away. But the explosion is brief. Then darkness returns. If you glance at the field at any random moment, what are the chances you'll see a firework currently exploding? Pretty small. Most of the time, the field looks dark, even though countless fireworks have gone off over time. That may be exactly what the universe is like. Civilizations ignite. They shine briefly on cosmic timescales. Then they fade, and because space is so large and time is so vast, the chances of two civilizations overlapping in time and being close enough to detect each other are extremely low. So the silence might not mean nothing has ever happened. It might mean that everything happens too briefly and too far apart to leave lasting traces. But there's an even deeper layer to this story, one that physicists find especially unsettling. It involves not just entropy, but probability itself. Because when you look closely at how complex things form in the universe, You find something surprising, extremely improbable events can happen, but only rarely, and life, especially intelligent life, may be one of the most improbable outcomes in all of physics. Not impossible, just extraordinarily unlikely. Think about how many precise steps were required for life to arise on Earth. Stable stars, heavy elements forged in supernova, planets forming at the right distances, liquid water, complex chemistry, self-replicating molecules, evolution toward intelligence. Each step depends on many conditions aligning. Now imagine multiplying all those probabilities together. You get a number that is staggeringly small. But here's the twist. The universe is so large that even incredibly rare events can still happen somewhere. That's why we exist. But the rarity means they might not happen often. And they might not last long. So when you combine everything we've uncovered, the speed limit of light, the vastness of space, entropy dissolving signals, the fragility of complex systems, and the extreme improbability of life, a picture begins to emerge, a picture that is both logical and deeply eerie. It suggests that the silence of the universe isn't surprising at all. It's exactly what physics predicts. Not because life can't exist, but because the conditions required for it to arise, persist, communicate, and overlap in time are so extraordinarily difficult to maintain. It's like trying to hear a whisper across an ocean during a storm while both speakers are drifting on tiny, short-lived rafts. And this leads us to one of the most haunting ideas in modern science, that the universe may not be a crowded, bustling metropolis of advanced civilizations, but a vast, mostly quiet landscape where complexity flickers briefly here and there before fading back into the cosmic background. And if that's true, then the silence we observe isn't a mystery at all. It's a natural consequence of the deepest laws governing energy, time, and probability. But once you realize this, another question arises, one that is less scientific and more philosophical, yet impossible to ignore. Because if the universe naturally suppresses long-lived complexity, if civilizations are rare and fragile, if signals fade and overlap rarely, then what does that mean for us? What does it mean for the significance of intelligence in a universe that seems designed to erase it? And perhaps most intriguingly, does the silence tell us something not just about physics, but about our place in reality itself? Because when you zoom out far enough, the question shifts from where is everyone to something much deeper. What kind of universe are we living in, really? And the answer to that question leads us into a perspective so vast, so humbling, and so strangely beautiful, that it changes how you see the night sky forever. You know, there's a funny thing that happens when you stare at a problem long enough in physics. At first it feels mysterious, maybe even unsettling, like something is missing from the picture. But then, slowly, as you peel away layers and look at the deeper rules underneath, the mystery doesn't vanish exactly. It transforms. It becomes something quieter, something almost elegant. And that's what happens when you really sit with the silence of the universe. Because at first it feels lonely, doesn't it? You look up at the night sky, all those stars, all those galaxies, and there's a natural human instinct to imagine that somewhere out there, countless civilizations must be looking back, that the cosmos should be buzzing with activity, that intelligence should spread, multiply, and fill the universe with signs of its presence. It's a very human expectation. After all, here on Earth, life expands wherever it can. Plants spread seeds. Animals migrate. Humans explore, build, connect. Everywhere we look in biology, there's this drive to grow and fill available space. So we instinctively project that same pattern onto the universe. But physics doesn't care about our instincts. It plays by deeper rules, and those rules tell a very different story. Because when you zoom out far enough, you begin to see that the universe is not fundamentally a place of growth. It is fundamentally a place of dissipation. Energy spreads. Structure breaks down. Order is temporary. Entropy always wins in the long run. And intelligence, no matter how advanced, is still a physical process. It depends on organized matter. It depends on energy gradients. It depends on delicate balances that must constantly be maintained. In other words, intelligence is not a permanent feature of the universe. It's a fleeting one, a transient pattern, like a whirlpool in a river. Now, a whirlpool is an amazing thing. It has structure. It has motion. It can even persist for a while, but it only exists because there's flowing water. Remove the flow, and the whirlpool disappears instantly. It doesn't leave a permanent mark on the river. And in a very real sense, that may be exactly what intelligence is on a cosmic scale. A temporary swirl of complexity in an otherwise smooth, ever-dissipating flow of energy. And once you see it that way, the silence of the universe stops feeling eerie. It starts feeling inevitable. Because the universe isn't built to preserve complexity forever. It's built to gradually smooth everything out. And this smoothing happens not through violence, but through gentle, relentless processes. Signals fade, stars burn out, galaxies drift apart, black holes slowly evaporate, even time itself stretches events farther and farther apart. The universe doesn't erase things dramatically, it simply lets them fade into uniformity, like ripples on a pond after a stone is thrown. Now here's where the story takes an unexpected turn, one that physicists often find strangely comforting. Because while entropy ensures that complexity cannot last forever, it also guarantees something else. It guarantees that complexity can exist at all. This sounds paradoxical at first, but think about it. The reason anything interesting can happen in the universe is precisely because it started in a state of low entropy, an incredibly ordered beginning. That initial imbalance created gradients. Gradients created flows. Flows created stars, planets, chemistry, and eventually life. So entropy is not just the destroyer of complexity, it is also its creator. Without the tendency of energy to spread out, there would be no movement, no change, no processes at all. The universe would be perfectly uniform from the start and utterly lifeless. So the same law that guarantees the eventual fading of intelligence is the very law that makes intelligence possible in the first place. And that's a beautiful symmetry. It means that complexity, life, and awareness are not accidents that violate the rules of physics. They are natural consequences of those rules, temporary, yes, but completely lawful, like waves that arise naturally when wind blows across water. Now here's the really profound shift in perspective. When you stop expecting the universe to be permanently filled with intelligent activity, and instead understand intelligence as a rare, fleeting phenomenon, the silence of the cosmos begins to look very different. It no longer says nothing is happening. Instead, it says something far more subtle. Something extraordinary is happening, but only briefly and only in tiny pockets. And we happen to be inside one of those pockets right now, at this very moment in cosmic history. Think about the improbability of that. We exist during a time when stars are still shining, when energy gradients are still strong, when complex chemistry is possible, when the universe is neither too young nor too old for life to flourish. This window, the era of complexity, is actually quite narrow on cosmic timescales. Billions of years in the future, the universe will be darker, colder, quieter. Stars will be rarer. Galaxies will drift beyond each other's horizons. New observers, if they exist at all, will see a much emptier cosmos than we do. In fact, they may never even know that other galaxies once existed. So we are living during a uniquely special period, a time when the universe is still young enough to be vibrant, yet old enough to have produced complex structures like life and intelligence. And that realization transforms the meaning of the silence, because it tells us something deeply important. We are not late to the universe. We are not too early. We are here during the brief era when awareness is physically possible. And that means something extraordinary. It means that the universe, through us, has become capable of observing itself, of understanding its own laws, of asking questions about its own existence. This is not a mystical statement, it's a straightforward physical one. Atoms formed in stars. Those atoms assembled into molecules, molecules into living systems into brains, and brains into minds capable of curiosity. In other words, the universe arranged itself through entirely natural processes into a form that can contemplate the universe. And that is astonishing, because it means that awareness is not separate from physics. It is a direct consequence of physics. A rare, delicate, temporary consequence, but a real one. So when you look up at the silent night sky, you can see it in two very different ways. You can see emptiness, or you can see something far more remarkable. You can see a vast cosmic stage where, in scattered moments and places, matter briefly becomes alive and aware. Where the laws of physics, through countless improbable steps, give rise to tiny islands of understanding. And those islands may be rare, they may be short-lived, they may never overlap or communicate, but while they exist, they do something extraordinary. They allow the universe to experience itself, to wonder, to ask questions like, why is it so quiet out there? And perhaps, in the grandest sense, that question itself is the answer, because the silence of the universe is not just the absence of voices. It is the backdrop that makes every fleeting moment of awareness profoundly meaningful. Like a single spark in an infinite darkness, not diminished by the darkness, but made more precious by it. And once you see it that way, the silence of the cosmos stops feeling terrifying. It starts feeling awe-inspiring, not because it tells us we are alone, but because it tells us just how rare, fragile and extraordinary it is that we are here at all, thinking, listening, and trying to understand a universe vast enough to hold both endless emptiness, away in the brief, beautiful phenomenon of awareness within it.